Hi there, this is Angelina and welcome to my channel. I am currently making a portfolio project series as a data analyst, and the series will be in 3 parts. Part 1 of the series will focus on importing, cleaning and exploring data with SQL. Part 2 of the series will focus on visualizing the data with Tableau. And Part 3, which is the final part of the series, will focus on exploring data with Python. So without further ado, join me in Part 1 of the series. The data set for this project will come from the U.S. Small Business Administration. As part of their COVID-19 relief assistance to small businesses, they offered what they call the Paycheck Protection Program, which is a loan that they gave out to the small businesses to help them pay their workforce. They've made some data sets available relating to that program. So all these spreadsheets, sorry, the CSV files here are related to the program. Also, there's a data dictionary that explains the data points on this spreadsheet so that you can understand what each individual data point on there means. If you look at the additional information, it appears that they last updated the data here on January 3rd. The next data set we would use is the US standards from SBA as well. Basically, it's called the NAIC codes. So go ahead and download the spreadsheet here. I have already downloaded all the files in my folder. So all the CSV files are here, and then I have the data dictionary in another folder. I saved a copy as a CSV. I also have the NAIC, which is a standards code here. I also save another copy as a CSV here. The next thing we would do is to import the data from point A to point B, which is importing the data from these CSV files into a database. So we use a tool called SSIS, SQL Server Integration Services. So I'll hit create new project, and the project type, I would go with Integration Services Project, and I'll go next. And I think I would name this import SBA data. Hit create. Let me maximize this. And then we will create a package. I'll just rename this package here, import data. Now the first file, okay, yes to all. The first thing we will do is to use a data flow task to import the data dictionary. And then we would import the other files as well. So data dictionary, I think I want to call it import data dictionary. Okay. Now in here, I would select flat file source because the file is a CSV. So I'll configure this new connection. Let me copy the path of my data dictionary here. So I'll paste the path. I'll go there, browse to that folder, and I'll change this to CSV. Select that, open, and then I'll change the name to data dictionary so that I can know the differences between the different connection strings I'm about to create. Now I'll put a test qualifier here. A test qualifier is basically in the event where the data has some type of delimiter in there that can cause the data to move from one cell to another, you put a double quotation in there to prevent that scenario. And then I'll go to columns. Data looks good. I'll go to advanced. Now, whenever you import data with SSIS, automatically it gives all the columns some type of length, the character length. It says they are all 50. But there could be cases where the length of the strings in this column could be longer than 50, so you can change them here. In this case, I want to change that to 255. 255, and I'll leave the name, probably change that one to 100. And then preview, I would say okay. And then columns. Okay, I want to close up the spaces in here to probably use an underscore or just close it out. It just helps to make your SQL queries easier to, type and retrieve the columns. because whenever there are spaces in the column names, you have to introduce the brackets. Is it? Yeah, the brackets in there to select the data from the database. So with this, you can just select the column name. Now on the error output, I would just select all of that and say ignore failure, and I will apply and hit OK. For the purpose of this project, I would ignore all failures. Now I use only DB destination to connect to my SQL Server database. So I'll go to new. Now the database we are using is called Portfolio DB, and I don't have it here in my connection string. So I'm about to create a new one. So hit new. And if you have SQL Server installed on your local machine, you can either do a dot or localhost, right? Localhost, like that. So for now, let's just do dot as a server name, and I'll change this to SQL Server Authentication, put in my password, and select my database. I called it Portfolio DB. Test connection, it's good, hit OK. Now select that connection you just created and hit OK. I do not have any tables in that database yet. Actually, let's check. Refresh. So this is SQL Server Management Studio. Okay. Now on the databases, I have Portfolio DB, and when I go to tables, there are no tables currently here. So we may have to create one from the SSIS tool. So I'll create new, and I'll change this to PPP Data Dictionary. Okay. Okay, I typed that wrong. Dictionary. Okay. Now we change the character to 100 and 255. It looks good. So I'll hit OK, and I'll go to mappings. It's already mapped. Nothing to be done here on the error output. I'll hit OK. Now let's see how we can get the data into the database. Right click on the task and hit execute. Okay, 53 rows imported successfully. Let's stop the package. The next thing we would do is to import all the CSV files. When I say CSV files, I mean all these files here. So I'm going to introduce something called a container. We are using a for each loop container here because we have lots of file in a particular folder. So I want the container to loop through the folder and pick all the files it sees. So under collection, I would change the numerator to for each file a numerator. And then I'll pass the folder name where I want the container to be looping through. And that will be this folder here. I'll paste it here. And I'll say, look into that folder, and for any file with the extension of a CSV, retrieve the name and extension, okay? And then map the name and extension that it's retrieved, that it can retrieve into a variable. And I'm about to create that. Probably call it PPP file, PPP, Paycheck Protection Program. And I just have to pass a name here. For now, I'm just going to select one of these. Pretend to be renaming it. Copy the name, paste it here, and add the extension to give it a starting point, right? So I'll hit OK. This is just an index to show that this is the first variable in the for each loop container. I'll hit OK. Configuration in the container is done. Again, I'll need the data flow task because that's where the data is actually going to be moved from one place to the other. Rename this to import SVA data. And again, I'll do flat file because it's a CSV. Select that, go to new, and call this SBA data. Do I have the path here? I need this path. Oops, not here, not here. I need it here. And then I'll browse to the path again, and I'll go to CSV, select one of them, hit OK. And again, I'll pass the test qualifier. Go check the columns. It looks good. Again, so you see here, there's so many columns and it's assigning all of them 50 as the length of the strings. I think I would, instead of going in there to change them one by one, they have this suggest types here. So I'll hit that and hit OK. And then I think it changed the loan number to integer. date to a date. So it changed it from 50 characters to whatever characters it's seeing in the spreadsheet, basically. I don't know how best to explain it. So I'll hit OK on that. And on the columns, everything looks good. Go to error output. I will again ignore all failures, apply, hit OK. Now you see the variable we created from the container is appearing here. For the sake of time, I'm probably going to create another variable here and I'll call it path. And I'll paste my base folder name here, folder path here, because I keep referring to it. So I'll paste it here and have that as a variable. Okay, now I need something called a derived column because I want to capture the file name into my database as well. So go to common, go to derived column, drag your data pipeline into derived column. And for the PPP file, I just want to use that as a file name in my table, destination table. Now the length is 27, and I think that would throw me an error because I picked the shortest of the names in here. All right, so let me just do a typecast and then convert this to a length of 35 or 40. Okay, 35 will do. And I will change the code page here to 1252 because I chose a string, and that is like what they call it? What do they call it? NSI codes, right? So I hit OK. Again, I would need to go to destination database and I'll use OLEDB. Now this time, because we are using the same database but creating different tables, I'll go ahead and use the same connection string. So I'll select that. I don't have the table there, so I would select this and create SBA public data. Let me see, my derived column is here. Okay, it looks good. I'll hit OK. Mappings, everything is mapped. Okay. Now, because I'm saying that look through the container and pass the name of the files, we see here the different files here with different names. Pass the name of the file to a variable. I have to modify this connection string to use something called expressions. So the expressions will help the connection string know which file name to pick next. So I'll change that under properties of the connection string. I'll go to, connection string, hit the expression here. I moved on to my other screen. Let me bring it. Now under the connections, remember we chose the folder path and the file name. So I'm just going to say that for the path here, which is this path I'm showing here at the bottom here, right? Always pick the file name from this variable. Currently, we just put a name in there, but then once it loops through and it finds another one, let's say 150K1, whatever the name is, it would pass that to this variable and then it would change this as it loads, okay? I'll hit OK, and then the connection string is going to change. We'll see an fx function, a function sign on here. Hit OK. That looks good to me. Now, for the sake of error handling or just for us to know which files have been already processed, I'm going to use something called file system task. And then I'll drag my pipeline onto that. And I'm saying that for the file system task, whenever you process the file, move the ones that have been processed into this folder, processed files, okay? So I'm going to copy that folder, and the folder path is not a variable. I'm going to create one. It's an existing folder and paste the path, hit OK. And the operation that I want to do is move file, and then move the file from the source, the SBA data. Okay, I'll hit OK. I want to call this move files to processed folder. I think configuration on this is complete. So let's right click on the container and execute. Let's see our folder. There's nothing here for now. Hopefully it works. If not, then it will give us the chance to troubleshoot here. Okay, one file has been moved, one down, Because there are so many files to process, I would pause the video, and once it's complete, I'll come back here and then we can continue. Okay, it seems to be working. We have one last file left to be processed. It looks like, yeah, it's moved all of them. So, okay, it moved all of them into this folder. Perfect. So at this point, I will stop the package. So the next thing we'll do is to import the standards, the NAICS codes, I guess. Now open that, we would again use flat file source. Where are you? Create a connection for that as well. We go to the same folder path here. Sorry, I meant to go here. I'll paste that, browse to that, and then change this to CSV. Select your file, hit open. Again, I'll do the test qualifier. Probably not relevant for this one, but let me just go ahead and do that. So I'll call this NAICS. Go to columns. Okay, for this particular file, I'm interested in the first two columns, the codes and the description. I don't care about the last four. Most of them are blank anyways. So I'll go to advanced and I'll change this to, well, they are codes. So I won't change this again. For the description, I'll probably change that to 255 and hit OK. Now in the columns for the output, again, I'll close out the spacing here just to help me with my query when I'm in SQL Server. Under error output, I'll select all that, ignore failure, and hit apply. Hit OK. Okay, now we will go straight to destination, SQL Server. Again, the table doesn't exist, so we create new. And I'll call this SBA industry standards. And I remove all the columns I do not need because I don't want to create them in the database. 50255, hit OK, it looks good to me. Mappings, good. Output, hit OK. So I would run this and execute task. Wow, that was fast. So we imported 1,149 rows successfully. I'll stop the package. Now let's quickly go into SQL Server Management Studio, refresh the tables. We created 3 different tables. Inspect the data quickly before we start our cleaning process. So let's look at the data dictionary. Okay, we have how many? 53. It tells us, so all these data, the field name are the data points on the main data set, the SBA public data. When we go into that, we realize that, okay, there's a loan number here, right? There's data approved. So basically that file contains 53 different columns, okay? This file here, or the data we have here, they contain 53 columns, and that is what we see in the data dictionary, I believe. Okay, so we have the loan number, data approved, SBA code, processing method. What is processing method? Yeah, the PPP. So they gave the first draw and the second draw. So that tells us which, for the particular loan, which category it falls under. So it was in the second draw, this particular one, and this one was the first draw. We have the borrower name, their address. We go through that quickly. The loan status, the date, the term, and then we have the current amount, and then initial approval amount. Okay, so I see there are differences. What does that mean? Current amount is the amount, the loan amount currently, and this is the amount at originations. So at the time the loan was approved, this is the amount they probably requested at originations. And then currently, this is what probably they gave them, or I don't know. So we go to the servicing lenders. These are the financial institutions that are probably helping the small businesses service the loans, like if they need to make payments, they need to send any documentation, I believe. I do not know. And then we have the business age, project city, county. Now, this will tell us the industry for which a particular small business fall under. And that is where we would use this second table here, this third table here, the standard. So in the data set, let's say you fell under 7.2, the first two, right? The first two, 7.2. I do not know where the first two, 7.2 will be under, but under the sector, we have the major sector and then we have the subsectors. So sector 11, we have a subsector called crop production, and they all start with 1 because the major sector is 11. Let's look at another one. Yeah, so we have the support activity. They all start with 1. So the major and the sub. I think I want to see another subsector here. Another sector, sorry. Okay, there's an easier way to do this. Let me not waste time. Okay, so we would use this in our analysis. So yeah, that's why we needed to have that the third table over there. So we have the race, we have ethnicity, okay? We have the payroll. What else? What else? We have the originating lender, the type of business they are, whether they are, the gender of the borrower, and whether they were once in the military or they served in armed forces, I do not know. So forgiveness amount, this is also a very relevant data point because the PPP loans they give out to small businesses, for some of them, they are not supposed to pay them back. They are supposed to be completely forgiven. So we would actually have some interesting analytics on that to see how much was given and how much has been forgiven so far. All right, so let's start the cleaning of data in SQL process with this table. SBA industry standards, I already selected it here. Now for this table, what we are hoping to achieve is this. At the end of the cleaning process, I expect to have the sector, the major sector in column 1, okay? And then the number of the sector, which is, this one is sector 11, the number of a sector in column 2 as a lookup code, and the description of the sector in column 3 as a sector description of the sector. So let me minimize this and let's get into it. The first thing I would do is to reduce the record set so that we can see only the records that we are interested in working with. Now, because we are interested in only the sector, I would select all the records where the NAIC code is blank because all the sectors have this column to be blank after my inspection of the data. So I'll do where equal to blank, right? So right now we have how many? 23. Now I don't need the first column here. So I just remove that from my select statement. Select this again. Okay, now the next step is to extract the numbers from the description column. We are going to introduce some system functions in here. So I just want to keep this and copy that. We'll use some SQL system functions and I'll go over the substring. 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 Okay. So the way the substring function works is that for an expression you give it, okay, it expects 2 more inputs. What it's expecting is that what is the index of the character that I have to begin the extraction process from? And then how many strings should I extract? So the index to begin the extraction from, I would say, is 8. Now, the reason why it's 8 is that sector is a string of 6 characters. And then there is a space after the sector, making it 7 characters. Now, the number 1 is on the index 8. So I'll start extracting the data that I need from 8. And then I need 2 characters extracted from that index. So I'll say 2, okay? So let's see how it works. And let me just give it an alias and call it lookup codes. So run this. Okay, so you see that we got all that we needed. However, on line number 7 and 9, we do not necessarily have a sector number on there to extract. It's almost like a subheader or something. So what we can also do is that we have to introduce something called conditional statements. I can either do a case statement or an if clause. This time I'm going to do an if clause. So I'm going to say that if in this column here, this column, that is a column name, I'm just copying it from here. If this column has any character, so I'm introducing something called wildcards, has a character like a dash, okay, comma, do the substring function. If not, after the comma, do nothing, right? Now run this. Ooh, interesting. Is that character not a dash? Hold on, let's find out. Good. Let me copy that. Okay, it looks longer than a dash, maybe two of them. Let me copy and paste it here. Paste that, remove this, run this again. Perfect. So we said that for the substring function that we did, it is only relevant for us to do the substring function if we have this character here, because I see that after the sector and the sector number, there's that character dash or double dash in the string, and it's working as expected. We could have as well done the same thing with a case statement. So probably let's try it. So let me call this lookup if, because we're going to do one with a case. So case when, I'll copy this again, when there's a character like this in here, in this case, we don't do a comma, we do then. Case when, then, what do? Then do the substring. Then we can have an else statement, right? Else what? We don't have anything else to do, so I'll just end it. And I'll call this lookup case, just to demonstrate how to use the case statement as well. So lookup case. Let's run that. Okay, so it's working as expected, because for the case statement, whenever the value evaluates to true, you get the results. If not, it passes you null, and we got null. But we don't need all of them to be working at the same time. So I'm going to comment this out and remove this comma here. Awesome. All right, so now let me just select the records that are relevant to me. I don't need row 7, row 9. So let's do a simple subquery here and say select. I'll select from this. So now this query here is being seen like a table, right? So I call it main, where, let me remove this. I don't want to call it lookup code if, lookup codes, or lookup code, where lookup code is not equal to blank. All right, I want all the ones with the numbers, so it's not equal to blank. And I'll do select star. That means select everything. So run this again. Perfect. So now we have only the relevant data points that we need from the standards, right? What we also need to do is that, we need to extract the sector itself. So I think I went too fast. I should have extracted it before doing the subquery. But yeah, we can quickly put that one here at the bottom. Let me remove the case statement. I don't need that. So for that, we would again use a substring, okay, to get a sector. Put my comma here. Now you see, for the lookups, it was easier for us to just determine where to start substringing the data from. All right. Now for the sector description, we do not necessarily know where to start from, and the length to extract. Over here, I knew that I needed only 2. So I'll use a function called length. Okay, for here, I'd say extract everything from that particular row. So let's say from sector to hunting, okay, assuming the length is 40, give me that in number. So the length will return a number, a numeric item here, a number. So let's say from mining to extraction probably is 66. So you will give me 66. So the function will change per the row that it's operating on, right? So we have covered the 2 here. Now for where to begin from, we will introduce another function called character index. Is it car index or char index? I don't know how to say it. Now I'll say that for this character here, okay, for this character in the column description, in the description column, retrieve the index of that character. Okay, so basically the function name works as expected, character index. So which character am I trying to find the index of? This character. And which column am I expecting to look for this character? Look into this column. Okay, now it would return another number. And I'm just going to say whatever number it returns, just add 1 because I need to cover the space after the character. Okay, so let's run this and see. And I'll call this sector. Okay, let me run the inner query first. Perfect. Okay, so now again, I do not need this on row 7 and row 9. So I'll do the if clause again. So if this, then do the substring, else do nothing. All right, run the subquery again, inner query again. Okay, it's looking good. So now when I do my select everything where the lookup code is blank, I expect to have the sector as well. So because I did select star, run this. Perfect. Okay, it's looking good. So I think what I also want to do is that I see some leading white spaces in here. If I copied this and pasted it here onto my query canvas, let me paste it here. You see there's a leading white space. I'm going to close them all. So I'm going to do something called L trim. And the L trim, I will do it on here. L trim, close that. Let me see what I have. No, did it work? Did it not work? Let's see. It did work. I don't see the space. Okay, so now I want to dump this results that I have in here into a table. So I would go with select into. Now select into is a very great way of making copies of your data set or result sets into SQL Server without actually creating the table first. So whatever name I pass here, this query is going to create a table with that name and then insert this results into that table. So let me see what I want to call this. Probably I want to call this SVA, NAICS, sector, right? It's sectors. So it's code and descriptions. Codes, descriptions. So after I run this script, I expect to have 4 tables now. So select into this table, that, execute. Perfect. So it says 20 rows were affected, meaning the table was created and 20 rows were inserted into that table. Let's refresh. Let's inspect. Okay, it's looking good. So now from this cleaning process, we have eventually, come up with another result set out of this table called standards to have this clean, refined data in here. Now, I think what we are missing again is that look at row number 5, row number 7 and 9, 7 and 8. They seem to have grouped some sectors. So manufacturing, they group sector 31 and 30, 31, 32, and 33 as manufacturing. And for retail, we have 44, 45. So assuming in the main data set, there was a code that started with 32, because I didn't have that in my code, it may reduce my result set by not, matching it correctly. So what I can do is that I can insert the 32 and 33 in here, and then 45 and 49 as well. I already have a SQL script prepared for this so that I don't waste time. So I'm going to copy that script here, and then hopefully the table name that I have is the same. SBA, NAICS, sector codes. Oh yeah, it's the same. So I'm going to insert. So what I'm doing is that, remember, the table has 3 columns. There's a description, the lookup, and the sector. So I'm saying for the description, pass this value. For the lookup, pass 32. And for the sector, pass manufacturing. Repeat the same thing, but this time change the lookup to 33 here. Okay. And the same thing for retail, trade, and transportation and warehousing. So run this insert. 4 rows. So now I expect to have 24 because we used to have 20. It's looking good. Okay. I think our cleaning process is, no, well, okay. It appears that when I said substring after this character, there were 2 of them in here, but I said substring after you see the first character here. So it took it from 33 going downwards. I'll just quickly write an update statement to clean this one up so that they all have manufacturing instead of 33 dash manufacturing. So I'll update this table and I'll set sector to manufacturing. Okay. And you have to put it in a single quotation because it's a string. And which one do I want to update? I want to update this line so I can say where lookup code. Okay, so because of the red squiggly lines here, my IntelliSense is not working. So what I can do to prevent that is to hold Control Shift R to get that going. And then once I type lookup, IntelliSense should work. There we go. Lookup code is equal to 31. So for this record here, set the sector to manufacturing, just manufacturing. Run that. All right, let's run this again. Okay, it looks good. Let me order by sector codes, lookup codes. All right, execute. So I think we got exactly what we wanted to, get from here. At the end of the cleaning process, we hope to achieve these results, and we have achieved it. So I think this data set is ready for us to use it in our analysis. So now we'll come back to the main data, the SVA select. I think I already have it somewhere here. No, I have it here. We will start the analysis by inspecting the data, which we already did inspect. But if you want to go through again, I just don't want to waste time on this, but there's low number data approved and all the good stuff here. Now, it has 53 columns or so. I'm just going to remove all of that and put star here, okay? Typically, you don't want to be doing select star, especially when you're in an environment where you have a lot of records in your table and a lot of columns. It really is an expensive query. So to guide the analysis and make things really fast, I have prepared some questions that we want to answer with this data set. The first one that we want to do is that we want to see a summary of all the PPP loans that were approved by the SBA. Okay, so to do that, I can quickly do a loan count. And the initial amount, we saw that there is an initial amount and current amount. So this is the amount at origination and current amount as it stands. So I'm just going to do some aggregate functions here. I'll do a count on the loan number. And I'll give it an alias and call it number of approved, or number of loans. I'll do number of approved. Comma, I'll do a sum of the initial approval amount, and I'll call it approved loans, approved amount, probably amount. And then probably we can also check the average. The average will help us know the loan size that was given out to these businesses. So I'll call it average size of loan size. Okay. And let's run this. Okay, so the first question, what is the summary of all the loans? Okay, summary of all the loans. We see that how many is that? I'm sorry, I need to be able to put in the comma to read this. 11 million unique loans, over 11 million unique loans has been approved by the SBA so far. And then in terms of the volume, the total net dollars, right? This is hundred, thousands, millions, billions. So 796 billion. I hope I said it right. If not, I'm sorry. But 796 billion has been approved by the SBA so far. And the average loan size is 69,473. Now, these loans were given out in both 2020 and 2021. So probably what we can do is that we can separate this result set and compare how much was given out in 2020 versus 2021, right? So we can go with the, what was it? I'm looking for date approved, okay, where the year date approved 2020. Let me just do a union so that we see all of them together. So basically, I'm trying to do something called set operators, use something called set operators. So the union is saying that for the result sets on top, which is result set 1, just append result set 2 at the bottom as well. So I'm going to do a union, and then maybe for us to know which one is which, put a year as well. No, and call it year approved. Year approved. I'll copy this and replicate it here. Okay, so for those of you that are very familiar with SQL, because I use aggregate functions and I have another column that is not with an aggregate function, I have to do a group by, and the group by will come after the where clause. So I have to do group by, what was that again? The year, so that my query doesn't fail. I'll put another one here. So I'll change this one to 2021. All right, so the total that was approved, we saw that is 796 billion. Hope I said the number right, but we want to see the differences between 2020 and 2021. Okay, so wow. So from the data, it appears that the unique loans that were approved in 2020 was actually lower in terms of the count of the loans, right? The unique number of loans. But in terms of the volume, the amount, the total in the dollars, the amount from 2020 is nowhere near, the amount from 2021 is nowhere near that of 2020. It looks like it's twice, the 2020 is twice the 2021 amount. And even the average loan size, wow, so the average loan size in 2020 was $102,000. I think it kind of makes sense because I think 2020 is when we had the lockdown, and then a lot of businesses had to, was it close temporarily so that we can do social distancing. So maybe that is when they really needed to get that money from SBA to pay their employees, I believe. I do not know, but that is my only understanding of the data at this point. The next analysis we can even do is that for all these number of loans that were approved, we saw that there were, at the data dictionary, there were the originating lenders and the servicing lenders. Originating lenders are the lenders that help the SBAs, sorry, the small businesses get their loans approved, the initial application process and getting funded, right? So let's see the originating lenders that were involved in 2021. So probably we want to do a unique count. So I would remove this just so I can keep this query. Copy this and bring it below. And I'll say count distinct rather than year. Count, come here, put it here. Oh, I know why. And then let me put this here. Okay, so now I would do a group by on the, I don't actually need a group by on here. I'll do the same thing and I'll just change the year to 2021. Run this and see, same result sets, just introducing one more data point. Okay, so out of the unique loans that were approved in 2021, right? Oh no, I needed to add this to make it easier. I don't know why I did that. So I need a group by again. Sorry. Let me copy that. At least I had it here. Because the query below doesn't tell me which one is 2020 and which one is 2021. So just to make it easier on my eyes. Okay, so the 2021 originating lenders, the unique originating lenders is 4,602. And that of 2020 means there were more different financial institutions and banks involved in the approved SBA loans as compared to 2021. Okay, I think that it will lead us to the next question probably we want to be able to answer. So what we can do is that we can find the top, let me paste it here, top 15 originating lenders by loan count, amounts that were approved, and the average as well. So I can do that by just copying this inquiry, and over here I remove the count, okay, and I remove the distinct as well. But this time around I will copy the group by and put it here. I'll copy the originating lender and put it under the group by, because I'm about to remove the year here, and then I'll do a top, I said top 15, so top 15. And I need to be able to do an order by, because the top 15 by what? In terms of amount, right? So I have to order by that amount so that I can know order by 1, 2, 3 amount. So number 3, descending order. Originally, if you do order by, it does the order by ascending order, meaning the smallest to the highest. But now I want to get the biggest to the smallest because I want to see the top 15. So let's run this for 2021. Okay, so in 2021, JP Morgan Chase was a top originating lender in helping the small businesses get funded for their for their PPP loans. And then Wells Fargo was number 15. So the average loan size that the JP Morgan Chase institution helped the small businesses acquire from the SBA was 77,000. I see. Let's compare the same data set, but 2020. Now in 2020, Cross River, Capital Plus, PNC, TD. Okay, so let's see 2020. So JP Morgan Chase again is number 1, but this time Wells Fargo is number 5. In the 2021 data set, they were number 15. I see. Okay. The next thing we want to do is to do the same analysis with the industry. So now we've seen the originating lender, but then we want to be able to determine which industry took how much, right? So I would say the question that we are trying to answer here, I'll put the question here. We want to answer the top industries that received PPP loans in 2021 and 2022. Oh, sorry, 2020. We would again use the same query as our base, but this time we'll introduce joins because we're going to need the join, and I'll call this SBA public data. So I'd say P public, and then I'll do an inner join to this table we created. Okay, inner join, I'll call this description, and I'll do the joining on the column P.NAICS code equal to D.lookup code. Remember, the lookup codes have only 2 characters, the numbers 11, 12, right? So now what I would do is that I would do something called the left. It's also another way to substring data, but this time I want to substring from the left side of the string. And I'll do the first 2, left 2. Okay, and then in here, I'll remove that and select D.sector. Now the D that I passed there is saying that give me the sector from this table, because I gave the table an alias. I call it D, right? So give me the sector coming from that table. Select that, and I said top 20, so top 20. And the top 20 would only work if I do my order by correctly. So I'm saying give me the top 20 industries that took the SBA loan. Again, I'll order by the amount received because that's the total net dollars in terms of volume, right? So I'll put that here, and then, okay, this is 2020, so let's run it and see. All right, classic copy and paste at its best. I need to put the I need to put a sector here in the group by. So this is a good error. One thing about working with querying with data or doing anything is that if you have an error, just understand the error and know how to fix it. Okay. So this one is saying that there is an invalid column here because I should have put the sector into the group by column. So that's exactly what it says. So knowing the error and knowing how to fix it is also very key to your day-to-day work. All right, so let's run this. Okay, so in 2020, healthcare and social assistance received the highest amount of the PPP loans that were approved. No, not received, were approved the highest amount. Okay, followed by professional, scientific, and technical services. They also were approved about, no, let me copy this number here because I don't want to make a mess by saying it incorrectly. Is this 69 million or billion? So this is 219,000, 5 million, 5.2. So they took 68 billion in total. Okay. And construction. Wow. In my mind, I expected accommodation and food services. I don't know how many businesses there are like that, but remember, we couldn't go to restaurants, we couldn't do so many things because we had to socially distance. And yeah, hotels, so many things were closed temporarily during that time in 2020. I mean, healthcare makes sense, but I probably thought accommodation and food services would be closely second, but that's not the case. Utilities down, management of companies and enterprises. And what is that? And we have to look into the details of the sector to be able to understand what are the businesses under this, major sector here. All right, let's do the same analysis on 2021. Okay, so my assumption seemed to work for 2021, right? Accommodation and food services per the data for 2021, they were approved the highest amount, followed by, wow, construction is always within the top three. Construction, then healthcare. This also makes perfect sense. And there's transportation, warehousing, retail trade, again, utilities, number 20. Okay. So I think the next analysis we probably want to do is to check the percentage they make. So we are looking at these huge figures, but what percentage do they make of the total volume given out, right? So let's do some quick percentages here. To be able to do that, I need to either use a subquery or because I want to be able to use this amount here, the sum, right? And now, right now, it's a derived column. It's not persistent in any of my tables. So I have to either use a derived column, sorry, a temporary table, a subquery, or probably a CTE so that I can do a division. So I can use this as my numerator, right? And have the sum of all these values here as my denominator for my percentage values. So let's probably do this with a CTE. So with a CTE, we have to start with a with clause, right? With CTE as, let me do the as, and then you put everything that I have in here into a bracket. Now I would comment out the order by because I don't need that in my CTE, and then I'll select from, so this thing that I've created here is now behaving like a table, just like I had selected from these tables here. Okay, so I'll put it here, and then I want the sector. Okay, I want the number of approved, and I want this count. Okay, and then I want the approved amount because I'm going to use the approved amount in my calculations for the percentages. And let me just copy the loan values. Now for the percentages, I would say that divide um, divide the approved amount by the sum of all the approved amounts. Let me see what I get. Sorry, I needed to do a window function. a window function, so I need to do over. Let's run this and see. Okay, now let's multiply that by 100. 100 because I want to get this like 15%, not in decimal places like that. And then do an order by, order by, order by 1, 2, 3, 4. So I'll do a 3. Well, I keep using the numbers like 3, descending order. I could as well use, what am I typing? I could as well use the approved amount, okay, as the name here. So run this and see. Okay. Oh, I didn't give it a name. Where is that? I'll call it percentage by amount. Percent by amount. That works. I think that works for me. Okay. So in 2021, okay, out of all the sectors that took the top 20 sectors that were approved for an SBA loan, accommodation and food services took 15% of the total approved amount in 2021. Then construction took 12%. I mean, I'm not saying all the decimal places. I'm just running it to the nearest whole number, okay? And then healthcare and professional, scientific, and technical services took 10% each, followed by other services, which we can find details of the other services in our standards table. For the purpose of this demo, I wouldn't go deep into that. Utilities and, okay, so from line number 17 to 20, they all took less than 1%. Now let's see the percentage healthcare. Remember in 2020, healthcare was number one. What was the percentage they took? So run this again. Okay, so healthcare took 13% in 2020. That makes sense. Accommodation took only 8%. I don't know why I expected that to be higher, but anyways, they took 8%. Then construction has always been there, 12%, 12%. All right, this is insightful. The next interesting analysis that we want to do is that, remember I said the PPP loans, we saw the data point forgiveness amount. We want to see out of the amount that were approved and probably funded, how much of that has been completely forgiven, okay? So I would copy one of my queries here. I want to speed up the process, so copy one of them here and remove this originating lender, okay? Remove the group by, so select count, and I'll do the current amount. This is the current loan amount. And I'll do the same thing here for the average loan size currently. So I'll probably call it current approved amount. And I'll call this current average loan size. Now I would want to add one more thing. I'll do a sum of the forgiveness amount, and call it amount forgiven. What we want to see is that out of the amount that were approved, how much has been forgiven, and probably do a percentage. So I'd say a sum of the forgiveness amount, assuming not all of them has been forgiven, over a sum of the current amount. Oh, I copied the average. I'll just change it here. I'll do sum. So, and I'll call this percent forgiven. Percent forgiven. Given. I like that. So run this. Let me do by 100 so that I'll see the percentage well. And if I'm confusing anyone with this, let me just do as. Put the alias in there. Okay. So yeah, we already saw the number of approved loans for 2020. We've seen the approved amount. At first, we were using the initial amount at origination, but for this one, I just want us to see the current approved amount in 2020, 521 billion, I believe. Put the comments in, please. And then, yeah, 521 billion were given out or were approved, sorry, in 2020. And out of that, 491 billion has already been forgiven. Wow. And that makes 94% of the approved loans. That is cool. So all the small businesses that were approved for the PPP loans in 2020, 94% of all of them has been completely forgiven, and they do not have to pay anything back to the SBA. That is interesting to know how much has been forgiven so far in 2020. Now we'll do the same for 2021. So this is 94.28. That is some interesting stats over there. Now 2021. Okay, so 270 billion were given out. However, only 63% have been forgiven completely so far. 171 billion. Well, probably they are still processing the forgiveness amounts or the amounts to be forgiven. So that's why we don't have a huge amount of them forgiven here so far. Maybe if we come back to the data after probably a couple months, maybe we have about 93% or 90% forgiven as well, just like we do for the 2020. Now, if I remove the year and just run the script, in total, how much has been forgiven, right? Regardless of the year. Yeah. So overall, 83% of all the SBA loans that were given out or that were approved by the SBA, according to the data set, has been forgiven. Okay. The total amount that were approved for both 2020 and 2021, 83% has been completely forgiven. That is great. Probably the last analysis that I can do is that we can check the highest month, the month where the highest amount were approved, because we see a significant difference between 2020 and 2021. So we can just take it a step further and see in which month, year and month, probably, year and month were the highest PPP loans approved. And I have already prepared a query for that, so we can speed up the process. Let me put it here. So let me explain what I have here. So I'm saying that for my public data, okay, called P, I can just remove that. Let me just remove that. For my public data, I want to see the year and the month the loans were approved, and I want to see the count and the sum of the approved amount, okay? And I want to group it by the year and the month, and then I'll do the order based on the amount approved or the total net dollars. So let's run this quickly and see. Okay, so yeah, so 2020 in April, okay, the highest amount of the PPP loans were approved. And that makes about, what was it? Let me see. I'm sorry, guys. I need to put in the comments. Am I reading this right? 425 billion were approved in just 1 month. And then in April, and then in 2021 February, only 81 million were approved, followed by 2020 again. So it appears, yeah, it completely makes sense that lockdowns, a lot of COVID impact in the economy, so many things were happening. So it makes sense that a lot of the approvals came in 2020 in particular. Oh well, this brings us to the end of our analysis or exploration of data with SQL. Hopefully we can build some cool dashboards in Tableau with this same data set in the next part of the series. I hope part one of the series was insightful and helpful to you. The next part of the series will focus on visualizing the data with Tableau, so stay tuned.